Hello students, hope you all are good. Today we will learn beta function. Beta function is one kind of uh, definite integral and it is Eulerian definite integral of first kind. Let's see. A great mathematician Euler introduced two type of definite integrals which are named as Eulerian integral of first kind and Eulerian integral of the second kind. The Eulerian integral of first kind is known as beta function and the Eulerian integral of second kind is known as gamma function. Next, what is the structural definition of beta function? Uh, First, we learned that beta function is definite integral and it is Eulerian integral of the first kind here. So for the definite integral, it must has two limits, and for that it has 0 as the lower limit and 1 as the upper limit. And in the integrand part, there are two parts. The first one is a variable x and the power is m minus 1. M is parameter here. And the second part is 1 minus x within the bracket and its power is n minus 1 and n is the parameter and dx. So any function like uh, 0 to 1, any variable, suppose y to the power 3 and then 1 minus y to the power 4 dy. See, this expression be in the form of beta function. Why? If you compare, you can find the power of y as y to the power 4 minus 1 and 1 minus y to the power 5 minus 1 dy. So, what are the values of m and n here? The values of m and n are 4 and 5 here. So, this expression is nothing but beta 4 comma 5. Okay, so this is the main structural algebraic expression of beta function. Any function, any function can be represented in the form of this is called the beta function, and we can treat like that. And what will be the process? What will be the approach? We'll learn after some time. Don't worry. So, see what is the next topic. Next topic is properties of beta function. What are the properties? The main there are four properties. These are main properties, and we learn some deductive properties that are also important. But right now, see and just try to learn these four properties. The first property is symmetry of beta function. That is, the expression beta mn can be again represent as beta n m. That means beta, for example, suppose 3 comma 2 can be expressed as beta 2 comma 3. Final value will be the same. Initial structure may be differ, but the final value will be the same. And don't try to establish right now. This be standard property. So whenever you complete this topic, after that you can verify using some approach whether beta function follow the symmetry rule or not. You can find uh, after that. Okay. Next, what is the next property? Next property is the representation of beta function in the form of trigonometric function. Remember this structure where lower limit is 0 and the upper limit is pi by 2, and the integrand part contains sine and cos function, and their powers are respectively 2m minus 1 and 2n minus 1. That means we can find or we can identify m and n from the powers of sine and cos theta. And since we just have learned the previous property that beta function is symmetric, so there be no doubt that uh, what is the value of m and what is the value of, that means which one is m and which one is n does not matter. Okay, for example, suppose 0 to pi by 2, normally sine theta, I'm writing sine theta, and cos cube theta. Okay, d theta. See, power of sine theta equal to 1 here. So we can represent this expression like sine to the power 2 into 1, that is 2, minus 1, that is 1. So verified theta, and cos to the power 2 into 2 minus 1. It is also verified. We can get from this expression 3. So theta d theta. Now the given expression, the given property B, beta mn equal to twice of this expression, twice of this integration. So from here we can write integration 0 to pi by 2 sine to the power 2m minus 1 theta, and cos to the power 2n minus 1 theta d theta equal to half of beta mn. You can write the property as this for our uh, own benefit. Okay, clear? So comparing this expression, we can find 0 to pi by 2 sine theta into cos cube theta d theta. It becomes half of beta 1 comma 2. Why 1 comma 2? As comparing the second property, we can find m equal to 1 here and n equal to what? 2 here. So half of beta 1 to be the answer. Okay. So we will verify it using the integration process, definite integration process of trigonometric function after some times, but don't worry, just learn the third property. After that, we will verify this one. Just remember this one. Remember this example. Okay, remember this example. Next, see the third property. Here, beta function can be expressed as sum of the two beta functions, where the first part b increased by 1 of the original beta function from the original beta function, and the second beta function in this expression, the second parameter b increased by 1 from the original beta function. That means given initial beta mn, the first part b equal to beta m plus 1 and then n, then second part is second beta function is beta m comma n plus n. Okay, so for example, suppose we have beta 4 comma 7. So we can write this 4 comma 7 beta function as the sum of the two beta functions like beta 5 comma 7 and plus beta 4 comma 8. Clear? Understood? Okay. So next we'll learn the fourth one, that is fourth property, which is very, very important, and it will be helpful to us to establish the or to find the value of the chosen example, that is 0 to pi by 2 sine theta and cos cube theta d theta. So for that I need to find some space. Okay, just I'm clearing, don't worry. I think we learned well from this expression, this example. So right now, no need of this space I'm using. And if you have any doubt, you can repeat the video and find the previous. Now see, I have chosen the example as 0 to pi by 2 sine theta cos cube theta d theta, and we can integrate it without any knowledge of beta function. Okay, and for that we need more space. So how? Go to the whiteboard. Don't worry, I have whiteboard also. Okay, so now tell me, what was the example? Yes, 0 to pi by 2 sine theta and cos to the power 3 theta. Okay, and using the substitution method we can easily solve this one. So for that, consider sine theta as any function. You can directly write like, you can do in two manners. Okay, so the first, you can consider y equal to sine theta, so dy equal to cos theta d theta. Okay, so there are three cos, and out of which one be consumed in dy, and in place of the sine theta you can write y, and cos square theta left, and in place of cos square theta you can write 1 minus sine square theta. Okay, so you can write 1 minus y square here, and then write dy. Also we have to change the limits, right here theta and y. For lower limit 0, if we put y equal to sine theta, there sine 0 stand for 0, so y equal to 0, and if theta equal to pi by 2, y stand for 1. Okay, so so right now we have integration 0 to 1, and this part algebraic expression we can elaborate this one. So y minus y cube and dy. So we have y square by 2 minus y to the power 4 by 4, and the limits are 0 to 1. Okay, so we have 1 by 2 minus 1 by 4, that is LCM be 4, and 2 minus 1, that is 1. So 1 by 4 is the final answer. Okay, and I left the right half of this whiteboard as we can use different techniques without uh, considering any sort of substitution. How? See, from this expression we can write, see very carefully. I left sine theta as it is. I left cos square theta, okay, and write d of sine theta. See, if you use this sort of technique, you can minimize your calculations uh, using the process. Otherwise, uh, for some sums, there may be more and more substitutions approaches, and that will be more pathetic. Okay, so consider uh, our variable is sine theta. Why? As after the d, after the d, everything left is called a variable. So right now our variable is sine theta here. Okay, so we have to change this cos square into sine square. So it can be written as 1 minus sine square. So it becomes sine into 1 minus sine square. Okay, and d of sine theta. This is our variable. Clear? And after the derivative of after the differential, you can get cos theta and d theta. Okay, so sine theta minus sine cube theta and d of sine theta. So as our variable is sine theta, so with respect to sine theta, we have to integrate the integrand part. So as before, just directly you can use sine squared theta by 2 minus sine to the power 4 theta by 4. Okay, next you can put the limits and you can find the value as 1 by 4. Clear? Okay, so what is the approach that does not matter? So I just uh, elaborate this one to uh, teach you people the different techniques. Okay, but our main concern is to establish or is to uh, find, is to verify the property of beta function. So we have to go back to the property of beta function where we left. Okay, so we need more space. Okay, now see what was the integration, that is 0 to pi by 2 and sine theta cos cube theta d theta, and we have just solved. Its value is 1 by 4. Okay, now using concept of beta function, we can write half of beta 1 comma 2. Why? As we learned earlier that any beta function mn can be written as 2 into 0 to pi by 2 sine 2m minus 1 theta and cos 2n minus 1 theta d theta. Okay, and compare with this expression, compare with this expression. From here you can find the m and n are respectively 1 and 2. Now there are fourth expression or fourth property You have to learn that also. What is that? If m and n are positive integers, if m n are positive integers, okay, then beta m comma n positive integers, that means natural number. You know, the set of all integers be like this. We have plus infinitive and minus 1, minus 2 up to minus infinitive. This is set of all integers, and out of which this part is called natural number, set of all natural numbers. So if an n and m and n are natural numbers, then beta mn can be represented as m minus 1 factorial n minus 1 factorial divided by m plus n, sorry, m plus n minus 1 factorial. Okay, so this is the fourth property. This is the fourth property, and we have to use this property to find the beta 1 comma 2. Clear? So let's try beta 1 comma 2 equal to 1 minus 1 factorial and 2 minus 1 factorial, and divided by 1 plus 2 minus 1 factorial. Okay, so here, you know, 0 factorial is 1, so and 2 minus 1 becomes 1, so 1 factorial is also 1, so 1 into 1, and here 2 factorial, that is 2. So this is 1 by 2. So beta 1 comma 2 equal to 1 by 2. So from here we have 1 by 4. So this is the main uh, magic of beta function, knowing beta function. If you know the beta function, you can mention that this expression is in the form of beta function, and you can easily find the expression of this type of integration where lower limit equal to 0, upper limit equal to pi by 2, and the integrand part contains product of sine and cos function. Clear? So no need to do the process that we did earlier. We did as in the previous page. See, uh, we did like two way, and that is why I just bifurcated in the two segments, right half and left half. But anyone you can do. But our main concern is uh, at the 10 plus 2 level, we did not know the beta function, and that is why for particular to solve this type of integration we have to use the substitution process. Okay, but right now after 10 plus 2 we learned what is beta function. We can mention the beta function as the formula. We can mention the beta function as beta mn equal to 2 into 0 to pi by 2 sine to the power 2m minus 1 theta cos to the power 2n minus 1 theta d theta, and comparing the with the given problem we can find m and n, and directly you can use the fourth uh, property to find the particular beta function where beta 1 to becomes half, and after putting the value we can get the value of 1 by 4. So you have to you have to write and you have to memorize all the properties of beta function, and there are few more properties that are called the deductive properties, and we will learn in the next video. Okay, and also we have to learn the gamma function, and then we have to also learn the combined problem related to gamma and beta function. Clear? So this is the end of this video. So thank you and keep watching and have a good day.